Bad.
Hello everyone, thank you again for everybody that showed up in person for Flutter Atlanta, and thank you to everybody tuning in online. Just a quick reminder for everybody here, we do have microphones in the ceiling so they can hear pretty much everything, so don't whisper to your neighbors and say mean things, because everyone on YouTube will hear it. Again, my name is Emmett Dean. I am the Flutter team lead here at Black Airplane, which is where this is hosted out of. I have a mobile development background, basically in native Android and iOS. I've been using Flutter for over 2 years, almost 3 years now, published a whole bunch of different Flutter apps, and I love Flutter so much that I'm using it for my own startup. I wanted to shout out Black Airplane. I wanted to thank them for food and beer that they always provide, and also allowing us to use this awesome space. Black Airplane is a leading development agency in the Southeast, and we have a special team here that produces top quality work, and we can build pretty much anything. Today we're going to be talking about Flutter offline capabilities. There's a couple reasons why I chose this for a topic, and one of them was we have had increased demand recently here. We've had a lot of people come to us recently asking about offline features, and I thought that was quite interesting because even in first world countries like the United States, that have normally easy access to internet, there's still a lot of offline use cases. So one of these use cases could be crowded venues, which is really bogging down the network, or buildings that hinder network, like complete concrete or metal buildings, or also rural areas. And it also can just help smooth out temporary network drops. Whenever you're driving and the internet just dips out for a second, you don't want your whole app to become completely unusable. So today we're going to be talking about some options. If you were here for my last meetup, we talked about animations, and I got to have a whole bunch of really pretty animations for that one. This one is going to be a little bit more technical with less stuff to show in that sense, so just bear with me for that. So there are levels to this. So your needs will heavily depend on the specific use case. There's not really a one-size-fits-all. But there are definitely different levels of complexity and different things you should choose based on what you need. So there is offline only, which is commonly used in Flutter tutorials actually, which is just local storage. So you don't need internet access at all, and normally it's used in tutorials because it doesn't require you having to go set up a server somewhere else, so it's easy to show people how to interact with data without having to get them to set something else up. Other thing is going to be cache results. So this is something that Firestore offers right out of the box. So this is very helpful if internet briefly dips and you're requesting data that you recently already accessed. So like if you basically went away from a screen and needed to re-request data that you have in the same session, it actually caches it in memory. And Firestore basically does all the heavy lifting for you. It already does this whether you know it or not. So this is not something you have to actually go turn on. There are some different settings that you can do to modify its behavior, but basically it's really just meant to help smooth out the internet blips. And then you have something called offline first. So Brick is something that I found by actually talking to a team of Flutter developers in the United States, and they built this as part of a very large corporation that they work for. So the company is called Dutchie. And what Dutchie actually does is they're a point of sale and also Uber-style delivery service for cannabis. And this industry has been booming, and they're worth multi-millions of dollars, having hundreds of millions of dollars acquisition. And they needed something to support offline for various point of sale reasons and stuff like that. So Brick is an open source system that they are still currently building out and is available on GitHub that we're going to talk about most today. And this is an offline first system, and if you really need full offline capabilities, whether you use Brick or not, it's definitely something that you should look at and consider modeling your system after. And then last is kind of a technicality, but it's peer-to-peer, and this is basically an effort to communicate to other local devices through something like Bluetooth so that you can mimic online functionality without truly being completely online. So first, let's talk about offline only, which is mainly going to be local storages. So the pros of this is you're going to have a lot of options. You have stuff like Hive, basically SQLite or SQLite, which is the Flutter version, and then like shared preferences, which is going to be built into Android and iOS. The pros, it's going to be very fast, and it can also persist through closing the app. So that's something that, for instance, Firestore can't do. As soon as you close the app, it clears the memory, so it's not going to persist those queries over the app lifecycle. but these can't. So this allows you to store your local data and access it between sessions in your application. And it could also be used as an online first fallback. In fact, SQLite is what Brick uses as that fallback for offline. So if you were going to build your own system to manage completely offline, you would likely use one of these while still interacting with some online database. And the main con to this is it doesn't take into account accessing data online at all. Next up is cache results. So the best thing about this is it's out of the box with Firestore, which is a very popular tool, and that it can cover brief online blips. It can also update changes upon reconnection, so that's something that Firestore does a very good job of. Once you start trying to write to changes or update different data in your database, even if you're not connected yet, it will update your local cache, and then as soon as you get connection, it has those queued and it will actually go and write that for you. The cons is it's not suitable for 100% offline. There's not as much customization, and it does not persist, again, over closing out your application. Next up is going to be offline first, which is Brick. So this works out of the box with both REST APIs and GraphQL APIs as the online source, and it uses SQLite under the hood to store data, which is pretty common offline system. And it does a lot of the heavy lifting for you. So it's going to try and make all of the complicated magic that kind of happens under the hood with offline and online at the same time happen without you having to deal with too much. And Brick does allow you to set if data should be offline or online first, negating really the only con, which offline first is normally not suitable for data that updates regularly. The last is going to be peer-to-peer, which is basically an online experience with no internet. The main cons of this is it's only going to work under specific circumstances. Basically, I have to be super close to other people using the same app so that way it can talk to their application. And it's normally pretty complex to pull off well. And there's also a lack of security if you're passing data around through other devices because everyone's device touches and accesses that data. So those are the main things for options that you have when it comes to offline and Flutter. There are going to be some other packages related to connectivity that you'll probably want to use whenever your application does go offline. You're going to want to make sure that you have a way of displaying that. But let's look more into Brick. So there's a whole bunch of different packages under the Brick ecosystem. So they basically have like a Brick core, Brick REST, they have Brick builders, which are going to be similar to Freeze to build out all of your data types. But let's basically look into their graph that kind of shows how this is working. So you'll see on the left side of your screen, you're going to have your UI components, your state management, and pretty much all of that is kind of just what's running on top of Brick. You're going to then have a repository that then when you query, it's going to first try and access your cache, which is going to be your most recent results. And if it doesn't have a solution there, it'll go to the slightly slower SQLite, which will then query the data that you have locally stored on the device. And then if it still doesn't have it, it will try and go hit the API to get that data. And then, of course, all of these adapters helps all of the different parsing and getting it returned in a way that you can use it. So they do have some options here. This is considered offline first, where if you were to just hit SQLite and it have the data, then it's just going to return that every single time. But Brick does have options that can say, always go hit the REST API or hit the REST API when you're able to, so that way you do have the most up-to-date data. Really, when you're doing your engineering based on your use case, the biggest question for you is going to be how often do you need to update this data? Should you always be hitting it, the REST API when you're online if you can? Or is it a whole bunch of data that you just need quick access to? And in that case, you're fine with offline first. You hit it once and then you can just use this older data. So I do actually have their little sample project running. It's not super beautiful, but we can show it off. Let's see here. Server.dart. So they actually have a little server written in Dart, which is pretty cool. So you'll see that it serves up here. And then I'll go ahead and run this. This will probably take a second because we're live streaming and everything. Let's check in over here. Are there any questions, Brandon, that you saw that I missed?
No questions yet. They were wondering who was typing so loud. That was me.
Sorry.
Yeah, these mics do truly pick up everything. Thank you everybody again for coming by. Hopefully this will launch for us fairly quickly. If anyone does have questions that they want to go ahead and get answered, please go ahead and ask them in the chat, and I will make sure to respond.
So is this demoing something that's going to both be accessing, as if it were accessing an online server as well as the offline mode?
Yeah, so you'll see the application showed up. This super simple application. It's really just hitting this API that's going to return a customer and how many pizzas that they've ordered. And you'll see down here in my log, it actually has the GET requests that it's hitting, and it's showing that it's hitting this. Now, if I were to refresh the app, since it's offline first, it reruns, but you'll notice it shows the data, but it doesn't actually hit the server again. So that's just showing that it's offline first, but all through their nice kind of magic code base, you don't have to deal with it yourself of actually accessing the online version and the offline version. It all feeds through one basic service that you can just say, I need this object, and then it will handle, do we need to go get it from offline or online. So yeah, again, their demo isn't the most sexy thing in the world, but it does kind of display how it's working. This is a good bit different than the animations from last time. It's much more technical and looking at kind of a diagram of how this is working versus pretty animations. But yeah, does anybody have any questions about online versus offline?
I think they use some kind of a e-tag trick or something. Like if they compare the e-tag, if it matches, nobody has changed the backend data.
Yeah. Yeah, so a lot of that will depend. When you're talking about truly offline, you won't be able to check to see if the data has been modified unless you have the internet connection. So that's really where engineering is going to come into play. Like, for example, if I wanted to make sure Twitter likes were as up-to-date as possible, then those change rapidly. So I'm going to have to make sure I go get the most up-to-date data rapidly. But if it's something like a whole bunch of user objects that don't change very regularly, like it's just their name and email, then it would be okay for me to only get that data once in a while, especially if there's a lot of it. I want to minimize how much data I'm trying to gather.
That example that you were just showing, that's using Brick, right?
Yep.
Is there a way you can maybe set the frequency at which it decides whether or not it needs to go look for new data again pretty easily? Because, I mean, what you're showing is pretty complex to implement by itself, but I'm curious what kind of helpers exist in this for.
Let me see. I looked in this earlier because I was also curious. They do have a setting. It's not quite as in depth as I would like, because I agree with you. There should probably be some settings on truly how often. So they have like the always hydrate, which is no matter what, going to go get from the REST API every time you hit it. They have await remote, which is going to try and get from the REST API, but if it can't, then it's going to return empty data. And then offline first, which is only going to get the remote if it needs to, and then offline only, and so on. But there isn't a real way that they have built in yet that is, this data changes often, go get it often. They don't have like a duration of if the data has been outdated for X amount of minutes or X amount of hours, make sure to update it. I think that would probably be a good enhancement though. And that's probably why, like this could be used as a good model, but there's definitely some changes here, just like you described, that could make it more useful. It
kind of looked like it had a way to wait for a remote host though. So is their pattern, they're trying to just wait until we have a remote connection again and then fire off those queries when that exists?
Yeah.
It's clever.
Michael had a question in the chat.
Brick does not currently support the Firebase local emulator. You could set it up to do that, but right now Brick is only set up to use REST APIs and GraphQL. I definitely could see you writing a Firestore adapter if you wanted to, or of course you could use Firebase Cloud Functions to simulate an API and then hit that. They use just the simple Dart server for the example because it's as simple as it could be while demonstrating the package.
From a business side perspective, are there any scenarios where offline functionality just seems like a really good idea but should not be implemented? Like it'd be more trouble than it's worth? Like what are the best case use cases for offline functionality?
The biggest one that we've run into with people that we've talked to is whenever it has to do with credit cards, because there's a whole bunch of liabilities that you incur as soon as you start dealing with storing credit card data offline. So typically, unless the client has a whole lot of money to ensure that their system is safe, it's just not worth the liability for most smaller companies. Now, Google Maps is a great example of needing offline functionality. It's going to download all of the route as soon as it can right at the beginning. And then while you're on your trip, it's still going to be gathering some data to see if there's a better route or the updated traffic information. But it has the entire current route in case you did go offline. It would still be able to persist through that while you're driving until you get back online.
From an architecture standpoint, I know you want to know as much as you can up front when you're building anything. Is this something that last minute can be like, oh, we should probably make this offline functional, or is this something that has to be done at the start?
Start's always going to be better. If you're building it yourself, a system out like this yourself, and you've organized it well, it shouldn't be that complicated of an add-in, because the reality is you're probably going to have kind of this first half of this system, or kind of the REST API through here. You're going to kind of have this half of this system. So if you've abstracted and organized in a decent way, you should be able to build your own custom system on top of this. But if you're having to build out your own custom system to work with your normal online version, it would take a lot more time than using something like Brick. Michael also mentioned medical data is also an issue in HIPAA guidelines. That's also a good point. So there are options that you can secure it that way, but like you can always encrypt data, you can always do this, but especially once you get into some options like the peer-to-peer, whenever you're starting to send data from device to device, that's where it really just falls apart, and it's very, very difficult to secure it.
How does offline functionality scale? Like I would imagine if you're getting millions of transactions every minute or something, it's probably gonna take a while. Is it for certain use cases in terms of scale?
Definitely. So Brick is great at demonstrating how to read data, and they do have options for upserting data as well. But there are a lot of considerations you have to take into account when you have a lot of offline devices trying to edit the same data, and then depending on which one's online, who has the most updated data, they get to update the data, but then all of the offline devices don't get the new updates. So that's something that Firestore was very good at, because it can kind of track who wrote what first and make sure they come in at the same time or the right time, and be able to kind of version match in a way that Git would to show the most accurate, up-to-date version. But no matter what, if you know that devices are going to be offline, then you want to minimize them trying to edit the same data while they're offline.
So going back to Brick, you talked about the interval, and not being able to set like an interval, how often to go check for new data or updated data. But your example of like the maps, those two in my head don't seem to work together without being able to say every few seconds we need to go look at the data to see if there's a better route. How does it really improve anything using Brick if you're not able to set that interval?
You could probably use some of these options to simulate that. So you could always have this offline first, and then you could make an additional request to get traffic data or check for a new route, and you could have that on the await remote, and maybe you would call that, once every however far distance you traveled, and then it's going to try and get it, and it's going to wait until it gets it, and then once it gets it, then it would update it.
Okay.
So there are ways to simulate that. The duration, though, I think would be a lot simpler to understand,
Right.
and also make sense for more applications.
You may have answered this in my other question, but how does offline functionality, does it handle race conditions with like simultaneous hits? Just timestamps them down to what, like a millisecond?
That all depends on how you build it. Again, really, the most of the work there wouldn't be done by Brick. It would be done on your server side as those come in to determine what means what. There are a lot of ways around that too. When I said try and avoid having people edit the same data when they're offline, you can do things like in Firestore, for example. A great example is like a distributed counter. So one of the limits of Firestore is how quickly you can write to a single document. So the way they get around that, if like I posted a tweet and let's say I got 100,000 likes within just a couple seconds, you would have a whole another collection that would record all of the likes as they come in, and then that distributed counter would just batch those every second and update every second. So that way you don't have everyone trying to access the same final number. You're just recording, hey, I liked this, and then a function on the back end is actually calculating the totals. So that's an example of trying to minimize accessing the same data.
Let's say you wanted to push up new data, so maybe you like something, and I would assume that can update SQ, I think it was SQ Flight, right?
Yeah.
F for Flutter.
Yep.
Okay. So it could update that right offline. Does Brick have some kind of way to automatically push up those updates when you have connection again?
Yes, so they do have a similar upsert policy. So optimistic local is going to save results to local before, and then waiting for the remote to update when it can. And then require remote is basically requiring it. It's not going to save it unless you can. So those are basically your two options. But again, that's not going to defeat race conditions if we're both trying to update the same data.
Usually in a lot of apps, there's a pattern at least where it tells you when you're not online, so you know it hasn't necessarily saved. But is it to make something like that?
Yeah, there's a lot of packages out there for that. I think one that we've used before is called Connectivity. And they also have like a Connectivity Builder or your Connectivity Plus. Yeah, discovering the state of the network. So this can even tell you whether you're online, offline, Wi-Fi, all of that different options. So you could use this in pairing with Brick to say, right now we want to be offline only because we're on like 3G. And then once we get to Wi-Fi, then we can require more calls to the REST API since it's more data.
Got it.
Thank you, everyone that came in late. Sorry, we started at 6:30. We're talking about a package called Brick, which basically allows for offline functionality through this kind of graph. So you basically make a query. It will check your memory first to see if it has it cached. And then if it doesn't, it will check your local SQLite database on the device. And if it still can't find it, then it would go hit REST. A REST API or GraphQL API, and then hydrate it from there. Brick was built by a team at Dutchy in the United States. Dutchy is a a big, I think, billion-dollar company now that's basically Uber and point-of-sale systems for cannabis. And it's completely open source on pub.dev.
Zachary has a use case. He's making an app for a local gym. He's been working on accessing a selfie library that is used at the gym when there isn't great service, and then it connects to being able to upload it automatically up to the cloud.
So you're accessing a selfie library and then you're trying to upload it to the cloud, so that there may be some offline functionality there, like if they had issues connecting to the gym or issues connecting to the internet in the gym, you could always use something like this as a kind of a backup if it wasn't able to upload right away. Or you could have it, again, use connectivity plus this to check if we're on Wi-Fi and only start uploading images if you're on Wi-Fi versus 3G. There's definitely some options there.
Is it possible to not have the app actively open on your phone and it push updates up, or does the app have to be in focus?
I don't know if Brick supports that out of the box, but there are like background processes that you can start on Android and iOS that can either continue or start uploads and downloads. It's changed a lot over the years, so the way that you have to do things is different now than it used to be. But yes, you can continue uploads and downloads when an app is closed.
Is there any like compliance or privacy regulations that you have to be aware of when diving into this?
When diving into offline?
Yeah.
It's kind of like the HIPAA regulations that they mentioned for like storing medical data offline on the device or storing credit card data offline on the device to process a transaction at a later date. Basically, the rule of thumb is if you store a customer's credit card number and then it gets stolen via the device and somebody goes by a Lamborghini, you're now liable for the Lamborghini. So it gets very risky very quickly, so you need to make sure that how you're doing it is very secure.
From like a user permission, like do you have to offer options for the user to be able to turn that off and configure their settings? Of like if I'm walking through the woods or something and it's uploading like GPS data to upload to the cloud once I get back to Wi-Fi.
Yes, so at least on the Apple App Store and Google Play Store now, they're all about transparency. So if you access that data, they make you request permissions in your actual code base, and then they also make you say why you need it, so that way they can display to their customers why you're actually accessing that data. There's always going to be sketchy ways you can get around it, but really if you get caught by an Apple or Google Play, not only will you be in trouble, your app will be taken down, but you could probably be in legal trouble too.
Crime doesn't pay.
Exactly. Don't be a malicious app developer. Anyone else got any questions? All right. Brandon, did you have anything you wanted to say to the people online before I cut the stream off?
We have swag codes specific to this Flutter Festival of North America. Exclusive. You can only get it here. So I'm going to put my email in the YouTube chat. Anyone who came in person just automatically gets it. But if you are online and you would like some exclusive Flutter swag, send me an email and I'll make sure you get one. And maybe we should talk about next month's.
You know more about that than I do. So
Next month's meetup, we have a celebrity in our midst. Trey here is going to be talking about in-app purchases. So it'll be second Thursday of the month. We are always the second Thursday of every month at 6:30. And Trey will be taking over Emmett's place, giving Emmett a bit of a break.
thank you, Trey. Awesome. Well, if nobody's got anything else, I'll go ahead and cut off the stream. Did you drop your email in there, or are you going to do MeetUp?
I did drop it in the chat, so send me an email. If I don't get any emails, I'll drop it in MeetUp. And then if I don't get any emails, I'll just use the coupons myself.